Well, good afternoon. Thank you for staying. Hey, and I'm very glad, actually, that I am not the last speaker before beer. Or I would have extra pressure to finish in a very short period of time. But yes, my name is Christopher Rude. My grandfather, by the way, had a company named Rude Electric, so you weren't actually far off. But my father started a company named Rude Lighting, and I'll get to that in a few minutes. But today, we're talking about sustainability, and I can tell you that from experience perspective of starting in the lighting industry when I was literally that high, we're going to talk about lighting and sustainability today. How do you change a 130-year-old industry? Think about a couple of statistics just for a minute. The A19 light bulb that Thomas Edison invented 130 years ago is still growing in the total number of units produced worldwide on an annual basis. Now, the rate of growth is shrinking. That's a positive sign. But more Thomas Edison A19 light bulbs are still growing in worldwide consumption today. We hope to change that and change it quick. Thomas Edison was the best, probably, person to give us that vision of how to do it. His quote up on the screen, "There is a better way to do it. Find it." And we hope we have. Another interesting statistic is the former head of Department of Energy, Dr. Stephen Chu, once said at a conference that I was attending, he said that general lighting, fluorescent, metal halide, high pressure sodium, general lighting is the last remaining vacuum tube technology that has not been replaced completely by solid state. Think about it. Computers, they started vacuum tube technology. They're solid state today. Televisions, they started vacuum tube technology with CRTs. They're solid state. Lighting is entering that revolution as we speak right now. So 1982, this was the garage at my house. My father is the one on the right. A man named Don Wanler was another one of our founders on the left. We started in Racine, Wisconsin, and it literally was started in the garage of our house. If you kind of notice the angle of the picture, the photographer was about this tall. And yes, that was me at the time. But started in doing that. My father is a graduate of Milwaukee School of Engineering and with a PE degree, and started a few companies along the way. But I was brought in, and yes, the first thing I was brought in to do was clean the floors and clean the bathrooms. Always fun, but worked my way up from there. Actually, I worked at some other locations as well. Got some of my own experience before coming back into the company. Another company, Cree, which we are now a part of, is the largest LED company in the world. Today, in the combination of Rude Lighting, which when we sold, we were the largest family-held lighting company in the world, to Cree, which is the largest LED provider in the world. But Cree only made the chips, made the little tiny 1 millimeter by 1 millimeter chips. They didn't make the fixtures. They didn't make the fixtures. We made the fixtures. So in the combination, basically, we now are vertically integrated. From quartz sand in on one end and the other raw materials that are necessary, all the way to the product that gets installed around the world on a basis. We are a publicly traded company now on the NASDAQ under the symbol of Cree, of all things, with revenues of about $1.4 billion this last year and about $1 billion in cash to continue our growth curve. About 6,000 employees. So that is what we do. We grow our own materials, we make our own fixtures, and we deliver the products to the market. When did that start? Started back in 1987 when it comes to lighting. These scientists from North Carolina found a way to make a piece of silicon, when you apply electricity to it, emit light. Emit blue light, most specifically. White LEDs are actually a blue chip with a yellow phosphor over top, and the blue through the yellow makes white. That was the start back in 1987, commercialized in 1989. We've come a long way since then. Rude Lighting started producing their first fixtures in 2007, along with another company that is now part of Cree as well to make downlights in 2007. So this industry, you'd think, is relatively new. Now LED technologies have been around since actually the 60s. First invented, and that's actually somewhat of a misnomer, but first invented and both claimed by HP and by GE, so I'm not going to try to win that argument of who actually did it, but HP originally invented the red LED to backlight their computer calculator screens, or calculator screens. The red initial digits were some of the first light-emitting diodes many years ago. So, why LED? How does that apply to sustainability? Why would you care about LED? Why should your business care about LED? What's important about it? LED, with today's technology, and we believe the LED curve of technology will continue to improve. With today's technology, we have the potential to reduce the US lighting load by 50%. That's over $30 billion worth of savings. You want to talk about sustainability. You want to talk about no new power plants. You want to talk about reduction in carbon footprint. You want to talk about things of that nature. And I'll get into that a little bit more and show you some practical examples of how LED is really at the forefront of sustainability. The US government is actually trying to promote this very heavily. Department of Energy has done a lot. There was a gentleman here earlier that was working on some case studies for me. But what does it do? What doesn't, and I'll pull it out here, what doesn't this bulb do? Was fluorescent really better in all ways than an incandescent light bulb? Yes, it saved energy, but did you like the color? Could you dim it? Did it last as long as they claimed it was going to? Did it really save the total energy that it was supposed to? In the end of the day, the US government, in their words, failed to promote this compact fluorescent light bulb effectively and or failed to make it work, because even today the adoption of CFL is only 14%. Only 14%. And most of that is in the commercial space where they tried. They didn't have to dim it. Residential, the number's actually much lower. Read some of the numbers down below just for a second. Widespread use of LED could save 348 terawatts of electricity. That's 44 large power plants. And I showed you the $34 billion number on the last slide. 44 large electric power plants just by the conversion to LED. City of Los Angeles. One of the largest, I'll call it scale projects to date towards the conversion of LED. Now the next photo I'm going to show you, this is the before. The next photo, excuse me, that I'm going to show you is the after. And the other thing I'm going to tell you about the after photo is that the light levels on the street in the city of Los Angeles when we converted to LED, the application level performance went up. The energy went down, light levels went up, and now the photo looks like this. It's pretty cool when you fly into it now. Next time you'll have to be looking out the window and see if you can see it as you're coming into LAX. This did not hurt the performance. What did it do? It reduced sky glow. The prior fixtures were sending light up into the stars. Was that helping the roadway you were driving on? No. Was that helping anything? No. It's wasted energy. That's really the impact that LED can have. Better control, better efficacy, and a better application. We can help the environment, you can help the application along the way. I'll come back to the City of Los Angeles' numbers in a bit. Here's another great example. I just finished the tour of the Land's End campus. There's buildings like this all across the world, all around the world. One office environment, 2,400 watts before, changed to LED, 640 afterwards, 75% energy savings. How about another one? Friendly's restaurant installed in 2007. Now, technology's improved. This data was done 2007. Over 5,000 watts before and less than 1,000 now. 80% energy savings, 75. So why is the Department of Energy trying to help? Because they're trying to spread the word. You notice my title, Global LED Adoption. This technology is real today. And people are just having to understand where and how it can be applied and where and how to best use it. So, is the adoption increasing? Yes. From 2010 to 2011 to 2012, in 2 years, 2010 to 2012, there's a 10 times increase. The DOE, this is Department of Energy data, believes that from 2012 to 2020, it's going to increase 100-fold. That was just the United States, by the way. Europe actually is more aggressive. Market share, still small. This, by the way, is all available on the DOE website, or this data is too. So I'm not showing you anything that you can't readily find, actually. Market share trend for LED is very small. But you'll notice it's also mixed between the purple and linear fluorescent today. That's the long tubes that you have typically in office environments. You also see some of the other colors. But that trend is changing to more LED all the time. Energy cost. This specific data decides to use $37 billion in electric costs, or 3.8 trillion BTUs. And it breaks it down, basically to show that office environments are about 70% of the energy consumption on a corporate campus or in a university or some of those things. 30% is outdoor, 70% is indoor. The opportunities exist in both. In fact, I noticed even driving up here, I'm a lighting guy, that Land's End has some LED products out front as well. So, this is what I want you guys to take away today. One of the things I want you to take away today. Make sure that if you're looking at an LED solution, you do two things. You meet the illumination performance, you meet the light levels. Because anybody can go in and take out every other fixture and your light levels drop and it's not a good work environment after that. Excuse me. There's no need to sacrifice your light levels to go to LED. None. One-for-one replacements, the technology exists, the fixtures exist today. And number two, it meets your economic performance requirements. Those also exist today. It meets your payback. How much do you pay for energy? What do you consider your cost to change a light bulb? Do you outsource that? That's easy. If you insource that, it gets a little more difficult, but you can put a number behind it. You don't have to compromise these facts from a sustainability perspective. Another story, the engineer for the city of Racine, Wisconsin, was having a meeting in his office, and he said, "Hey, Chris, I just have to tell you this story." He said, "I was given a budget this year of $300,000 for energy efficiency." He said, "And I did this exhaustive study of all of the things that I could think of to save energy. I did solar, I did wind, I did chillers in the basement, I did double pane windows, I did LED lighting attached, I did solar LED lighting." He said, "You know, the best thing I found was connected load LED to give me the most energy saved for the dollars I spent." Now sure, you can go solar and you can pull 100% of that energy off the grid, but your cost for that amount of energy was like 4 times higher than the amount of energy you could save with a connected load LED solution. So when you're looking at how do you maximize your benefit to your organization, think about that. The life cycle cost analysis is another thing. Just one more thing. Make sure when you ask the question to whatever fixture manufacturer, to whatever contractor, how long is it going to last? How long am I going to get that light output? Because I will tell you now, one of the biggest paradigm shifts from traditional lighting, fluorescent, metal halide, anything, is the lamp life used to be determined by the bulb you screwed in. The lamp life used to be determined by the bulb you screw in. If you go with an LED fixture now, there's no bulb. It's now determined by that fixture. Lamp lives vary from fixture to fixture now. That didn't used to be the case. So manufacturer A compared to manufacturer B, not only do you have to look at light output, but you have to look at how long you're going to get that light output. So what are those things that provide the higher value? You get energy savings. You get longer life. I'll get back to that. Better efficacy of LEDs mean less heat. If you're putting less heat into the space, you're also having to take less heat out by air conditioning in the summertime. Color quality. Remember, I go back to that curlicue light. Color quality there is not as good as LED. LED is much closer to a full spectrum. You get much more variety of light output options. That's what it means. Plus, LEDs are a point source, literally 1 millimeter square in most cases. How do you control a single direction, 1 millimeter square source? Much easier than a big round tube that emits light 360 degrees, even if you only want the light to go 180 degrees at best. You can gain a lot of efficacy by doing that. And this last one's also very important. Vacuum tube technologies, fluorescent, metal halide, do not like to be dimmed. In fact, when you dim them, it shortens their lamp life and it hurts their efficacy. LEDs love to be dimmed. They last longer when you dim them. They actually get more efficacious. The lumens per watt, the brightness for the power actually gets better when you dim it. So we have another change of paradigm where solid state lighting is going to take over. So you've seen 3 different types, right? You've got your A lamp. You've got 140-year-old technology that's still in use today. We talked about the push towards CFL lamps that my wife refuses to put in our house, even for the last 10 years. And you're getting all the way now to LEDs that look like a traditional light bulb that hopefully you all took a sample home in your bag. Why is that important? Well, besides the fact that it looks like a light bulb and it gives the light out like a light bulb, there's also a long life. It lasts for a long time. Not only is it 25 of the regular Thomas Edison bulbs, but it's even 5 times the CFL. In fact, I think that number is actually closer to 10 times the CFL based on practical usage. It's going to last as long as the lamp that you're putting in. So, time to switch topics. LEDs are important. LED fixtures are important to sustainability. Energy savings is real. But remember the comment I made a minute ago that LEDs like to be dimmed? If LEDs like to be dimmed, you can actually extract even more energy savings if you want through the use of controls. There's 2 types of controls that I want to talk about briefly today because they're both important and they're both valuable. Network-based controls, like there may be a network in this building that at the push of a button it can turn every light off. Or in a lot of the new buildings with daylight harvesting, there's a sensor and the network can lower all the lights within where near where the windows are. There's also unitized controls or non-network based but occupancy sensors. Bathrooms are not network controlled, but you walk in, there's a sensor that turns on the lights. There's some other applications where unitized controls are working even better. Office environments are very common. In fact, in states like California with Title 24, they're mandatory and growing in the use. This year, Title 24, starting in 2014, is requiring the use of occupancy-based controls even outside in parking lots. We can do that in both networked or individualized fixtures. But a control element is more than lighting. A control element, if you can turn the lights off, you're also not having to cool the space as much like we talked about. The control element can also work on the whole backbone of things from an HVAC perspective as well as for security, fire protection, and lighting. So you have your energy, excuse me, and other operational savings. You also have your productivity enhancement. Does the lighting need to be at the same level all the time? Does the task at hand require more light or less light? Customizable controls for lighting are going to get greater and greater. In fact, mandatory in some states and with some of the new ASHRAE codes that are being proposed. So when you monitor a location, you monitor a site, you monitor a building, you monitor a warehouse, you monitor a parking lot, there's really those three things that you have to look at. What are the sources? What are the controls that you're using? And what are the sensors necessary to do that? Because there's a lot of types of sensors that do a lot of things today. Are they necessary that the sensors for your HVAC system be separate than the sensors for your lighting? Or the sensors for your fire? Or your sensors for your security? They're not. In fact, most of the time, you can bring down the total cost of a new construction project if you can integrate those sensors into a single type of an environment, into a single control solution. You can make them work together, not only lowering your first cost, but improving what you can do in that environment, in that space. So there is, believe it or not, a standard out there even for how to do it. It's called BACnet. BACnet has the ability to be an interoperable standard among all of these systems. It's not used quite yet by everybody, but it should be. For future systems, having that interoperability gives you nothing but more flexibility and more freedom to control your environment and to have the most sustainable solution possible for what you're trying to do. It can control HVAC. It can control security, fire, and lighting in that process. Sensors are the next kind of big thing out there right now. There's more and more sensors coming all the time. There's wired, where the power won't go out. There's a lot of people trying wireless sensors right now. I get really nervous about a battery controlling whether or not the fixture's going to work, that it's powered by wire. But they exist. They're easy for the contractor. Stick it up there with a piece of double-sided tape and he's done. But all of those things exist. Coverage, accuracy. I mean, how many people have stories about the original occupancy sensors in bathrooms where somebody was sitting down with a closed door and the lights turned off because they weren't moving fast enough? Sensors are getting better. But this is still where the technology is improving, and you should ask as many questions in your system about what types of sensors, and maybe even try what types of sensors are being used to make sure that that solution is as robust as your lighting or your HVAC in the end of the day. Because it's definitely making some great progress. Another topic came up. I was talking to somebody earlier today. They're saying, hey, you know, we've got this campus and our campus security guys love your new lights. And I said, really? Why do the campus security guys love them? He said, because all of the people show up so much better on camera than the old lighting. And he was specifically in this case referring to a parking lot which had the orangish light that's called high pressure sodium, which is a very narrow wavelength light and not very good at rendering colors or dimensions. It still registers shadows, but when you're now talking about improving your situation for security, for free basically, because it comes along, you know, you don't have to deal with that orange light anymore. This is another benefit. The police department in Oakland, California also recognized the same benefit in the DOE gateway study done on LED street lighting. You're going to do things, you know, here even with the controls, where security recognizes a problem, they could send a control to fixtures near that location and start flashing them, blinking them. LEDs turn on and off instantly. It's not like fluorescent that takes a while to come up and a while to go down, or metal halide, which you don't turn off because it takes 15 minutes to cycle power on. But LEDs, so that people in that area are aware that something nefarious is going on, could blink rapidly while a first responder is coming to the location. All of these technologies are starting to become enabled by LED. Here's a great example of part of the parking lot before the orange, part of the parking lot after in white. 50% energy savings, no reduction in minimum light levels. Which do you think people would feel more safe and secure under? I think the white light. What about, why is the high pressure sodium such a wasteful technology? Well, first of all, the light source is 360 degrees. So you've got to put reflectors in it and has to go through glass to protect it, and you lose a lot of efficiency that way. But second thing is, notice the hot spot directly below the fixture? Notice all of that light that's sitting directly below the pole. Do you really think you need that much light directly below the pole and a lot less light between the poles? No, you really don't. You want to try to make that light as uniform as possible. That's where the directionality of the point source of LEDs really help you, where the new technology is enabling things that was not practical and feasible in the prior technologies. So, some other interesting observations. Luminaires, light fixtures, are typically the most prevalent object in a commercial building space. The most prevalent object in a commercial building space. All right, so if you're trying to save the most amount of energy in your building, where do you think you should start? How about with the most prevalent object in your building? We talked a lot about building automation. If there's a way for the fixtures to somehow network back in, because they're already there and in the most locations of anywhere, there's a lot of cool things coming. What else? Warehouse. We just took a tour of a warehouse today. What else can you do with warehouse lighting? Some are 24/7, but how often do they go down every aisle? Even the Land's End tour that we took today, several of the aisles had occupancy sensors, the lights were off. It's perfect. That can be done and should be done in a lot of warehouse applications. You can do that for many different applications. Office spaces, cubicles, warehouse aisles. What about optimizing the lighting for even inventory placement, tracking? Turn the lights on in front of somebody. Link the systems. Remember, these are now ultimately controllable. You can even increase the light if you got a lot of people in an area to make sure that they see each other properly, instead of it's just one person going down a dark aisle. Parking structures. Another DOE study was done at UC Sacramento that showed that a high-use parking structure, which the university is considered, because they have classes 20 out of 24 hours a day, has people in it 17% of the time. A high-use parking structure. So, there's a professor at UC Davis that was also talking about safety and security. So if your light is on 100% of the time at full brightness, do you know that somebody's lurking behind a car, a bad person ready to jump out? Burglar, hopefully. Or what happens if you don't have lights on and all of a sudden the light turns on in your peripheral vision? Is it going to add a sense of, hey, wait, somebody's over there, something turned the light on? You can do things with instant technologies now that were really not feasible and practical. So great, 80% of the time you don't need to have the lights on. If you want to have them on even a small amount just so that you can see through the field of vision, that's great. But we took a 60% energy savings project down to an 89% energy savings project by adding occupancy sensors to parking garage lights. More than paying for the added cost of the sensor. The technology is there today. But like we talked about earlier, adoption is still small. So again, from the DOE, how small is small? Well, how about less than 1% in 2010? How about less than 1% in 2012? We got a long way to go. A lot of opportunities. Remember, I told you that there was more than a tenfold increase, and yet that percentage didn't change from 1%. So going back to that city of Los Angeles example, how about some hard facts? So they've replaced about 140,000 streetlights with 63% energy savings, and right now they're saving over $7 million on just energy, let alone the maintenance side of things. In one city in the United States. Imagine doing that globally, what the impact is on our environment and sustainability. 140,000 lights. Yeah, those are street lights. But does it have to be? What about office buildings? How many thousands of lights exist per floor of an office building? The numbers are staggering. Remember, 70% of lights are inside, not outside like that. Installed base of LED, this is the largest number we have as far as a percentage of installed base of LED on a global basis. 2%. The opportunity is still there. What about offices? So troffers, fluorescent troffers, the things that hang in the ceilings. Linear fluorescence, the 4-foot T8 or T5 tubes. Doesn't even register on the scale yet. Doesn't even register on the scale yet. But it can be done. We do it in office environments. We do it in hotels, restaurants, retail, better color. Interesting about retail, that's another case study that was done by Walmart. Walmart switched to LED lighting in their produce section, not to save energy. The reduction in forward UV made their fruit and vegetables spoil slower. They were able to find a practical example of less forward UV, less heat, actually made their produce last longer on the shelf, which is by far a larger cost to them than the energy that they saved in the process. There's some cool things out there that a new technology enables from a sustainability perspective. Imagine that cost of throwing away all of the spoiled fruits and vegetables. And what is that environmental impact above and beyond the electricity savings? Auditoriums, site lighting, parking structures, campuses. Signage. We talked about Wingspread earlier today too. Wingspread's been a very big advocate of some of the energy efficiency and savings as well. And finally, residential. So I hope you all take those light bulbs home, throw them in a lamp, see if anybody else even knows that it's LED. My guess is they won't. I put mine in our house. I put our first one in my house for over 3 weeks, and my wife didn't notice. She used it, turned it on every day, didn't notice. I finally told her, just because it was bugging me. Which is good. That's a good thing. That you can change something that was 60 watts down to 9 watts and nobody notices. You know, that's what we all aspire to be able to do, right? To have that positive impact on the environment without the detracting. You know, there's always that cause and effect. There's always that yes, but. There's always that thing. No. What else is wrong with this lamp? It contains mercury. In fact, it contains a lot of mercury. You know, if you do a research on EPA, Environmental Protection Agency, was called by a concerned mom who was standing on a chair in her daughter's bedroom trying to screw in one of these light bulbs. She slipped, the lamp fell on the ground, broke on her carpet, and she's like, I've been told that these have mercury in them. What do I do? Do I vacuum it? Do I really want that? You know, my vacuum filter's not going to stop all of the dust. She says, I don't know. Well, let me call the poison control. So she called poison control. They said, I don't know. Poison control took her to the EPA. EPA said, hey, we'd love to come to your house. This happened to be down in Atlanta. EPA had an office there. We'd love to come to your house with all of our gadgets and gizmos and, you know, meter readings and things and just check what it was. So they did. They showed up about 3 hours later, which is slightly unfortunate. They've since redone that. But they looked, and in their daughter's bedroom, there was still what the EPA considers a toxic level of mercury, parts per million, and I forget what the exact number was, floating in the air after 3 hours. So the official recommendation, definitely number one, do not use the vacuum cleaner, because that makes it even worse. Number two, their official recommendation was to cut out a 2-foot square portion of her carpet and have it hazmat clean, you know, basically thrown away in a red sealed hazmat container. Well, now you got a piece of carpet broken, you got, I mean, all of those things, all for breaking a tube. Now that's not the practical answer, but that's what's in here, and that's what the EPA found. You know, it was republished actually by the Wall Street Journal and a few other articles since then. But fluorescent technology, the 4-foot tubes have mercury. The U-shapes, all the fluorescents do that. LED does not. Solid state device. It's a rock that when electricity is applied, emits light. Much safer for the residential environment, much safer for every environment. Finally, hopefully, Dr. Stephen Chu will get his wish of LED will be the last remaining technology to replace a vacuum tube technology. So with that, thank you.